example is in your packet. It is on page, I think it's 11, has to do with creating confidence interval for proportions. Problem sets, proportion of drivers who use seatbelts depends on things like their age. Young people more likely to go unseatbelted. Gender, women are more likely to use seatbelts, but it also depends on the local law. New York City, police can stop a driver just for not being belted. In Boston, when this study was conducted, police could cite a driver for not wearing a seatbelt only if the driver had been stopped for some other violations. So they give you some data for observing random samples of female Hispanic drivers in both of those cities. Construct and interpret a 95% confidence interval for the difference in proportions of female Hispanic drivers in the two cities who wear seatbelts. So this is a problem where we're going to panic. So let's start with the P in panic. P is, what are your parameters? What are we trying to study? So what we're trying to do here is we are trying to estimate the true difference in proportions of Hispanic women who wear seatbelts. Let's define what's what. We've got two cities here, so we're going to go ahead and call the New York drivers. Why don't we just call that proportion New York, and we'll proportion Boston for that one. Just in case you're wondering, here we've got P hat for New York. 183 out of 220 comes to 0.83. Proportion for Boston comes to 68 out of 117.58. So certainly less in Boston. All right, so we've got our parameters all named and labeled. And yes, the AP graders will look up in this area to see if we have any writing there, and they will count that. So, alright, so let's take a look at our random samples. Our random condition is stated up in the column. If we go next to the normal condition, this is where we check NP, which we check for both New York. Let's do New York first, and that would be, what do we have? 220 drivers times 83%, that is 183 greater than 10. We will also check N times 1 minus P. That would give us 270 times 17%, that is also greater than 10. In New York, let's look at Boston. So looking at Boston, we do the same thing, and P, N will be 117. And P is 0.58, that's more than half of 117, that's good. And N1 minus P will be 117 times 42%, that's still greater than 10. So the normal condition is met. Then we look at the independent condition. For independence, I think it is safe to say that both cities will have populations that are greater than 10 times 220 for New York and 10 times 117 for Boston. So that's such. So all three conditions look good. PAN, ion is next. So let's come over here. I'm going to come over to this area now, and we'll talk about step I. So step I, create name your interval. Actually, I forgot step N. So name your interval comes first, and our also name it by formula because the graders would like to see it in case they don't like what you named it up here. So we will have the sample proportion from New York minus the sample proportion from Boston. And we're going to add and subtract that to some z value times a big square root. And that big square root is going to have the proportion for New York. There's 1 minus proportion New York. And then the n New York. And we'll do the same for Boston. Minus P for Boston. Yes, there's one like that. So, and Boston. There you go. So there's your formula. Let's figure out what's what. We already have labeled what our p-hats are. Our p-hats for each of these are listed over here. So we're going to do 0.83 minus 0.58 plus minus. We need to go and find a z-score for a 95%. I think we kind of know what that is already. It's 1.96. It's a school district. Right, so we got that. Now we're going to go 0.83 times 1 minus 0.83, which is 17%. N for New York is 220 plus. Now we got Boston is 58%. 1 minus 58% is 42%. And Boston had 117 people in their study. So I go ahead and do some calculating and crunch my numbers, and I come up with 0.25 plus or minus 0.102, and that is my confidence interval. So what I did here was step I. Now I'm going to finish this up with step C, and step C is to interpret that. So we would say we are 95% confident that a true difference in proportions of drivers, yes, technically female Hispanic drivers, who wear seatbelts, is in the interval of, then I can go and do the arithmetic here, the interval of 0.15 through 0.35. I rounded that to 0.10 to make my math a little bit easier. So there you got the entire confidence interval. It looks good. I covered all of my bases. There is a part C to that question. Based on the laws in those cities, we would expect a smaller proportion of drivers to wear belts in Boston than New York. Does our confidence interval give good evidence that this is true? And I would have to say, yes, that's true, because in this confidence interval, all of our values are positive. Since all values are positive, then that tells me that New York is greater than Boston, because I always get a positive difference. So hopefully that helped a little bit. Let me know if it did. Thanks.